Hello, my name is Sylvianne Njiki. I'm a PhD student in environmental science at Jackson State University. And today our study is on anti-cancer potential of garlic powder extract in the management of acute promyelocytic leukemia. The extract that we use is from garlic, which is an herb and also have around 4 feet in head and is native from China, from Asia, where China is by far the largest producer. Garlic has been used as food conservative and also spices in many of our dishes. As a medical use of garlic, historically, garlic has been used around the world since ancient times for the treatment and prevention of many diseases. And as prevention, we has should prevent bacterial and fungal infection, also lowering respiratory problems, reducing common cold, reducing high blood pressure, and also used in the prevention of cardiovascular diseases, as well as the prevention of many types of cancer. And talking about many types of cancer, garlic has been used in previous research to reduce the risk of esophageal cancer by 57%, of laryngeal cancer by 44%, also to reduce the risk of ovarian, prostate, and breast cancer. Leukemia, the disease here is a malignant disease characterized by an unregulated proliferation of blood cells. And leukemia is actually classified into major groups, which is and chronic, acute and chronic. So here in normal hematopoiesis, this is how the normal blood cell differentiate. But when the cancer occurs, the transformation will happen, and we're gonna have this four for the leukemia. We're gonna have this four type of leukemia. But our focusing case type of leukemia here is the acute myelocytic leukemia. So acute promyelocytic leukemia is what? It's the subtype M3 according to the French American British classification, which is characterized by the translocation of the chromosome 15 of the gene located on chromosome 15 to the gene located on chromosome 17, forming the fusion, which will give us the PML retinoic acid receptor fusion. So, and also APL represents 5 to 8% of all AML. And the cell line used here is HS66, which was derivative from the peripheral blood of a 36 years old woman with APL. As a rationale, even though the medicinal use of garlic for the prevention and treatment has received increased attention in recent years, there's not that much information available in the literature review regarding its use for the management of APA. Therefore, the aim of our present research was to assess the therapeutic efficacy of garlic powder extract against APA. So we hypothesized that garlic extract in vitro treatment will cause cytotoxicity, DNA damage, and apoptosis to HSCC cells. And the goal of the present study is to assess the therapeutic efficacy of garlic extract in the management of APA. So to accomplish this research, we set three objectives. The first objective was to use HSCC cells as a test model to assess the cytotoxic effect of garlic extract on HSCC of garlic extract on HSCC cell by MTT and Trypan blue exclusion test assay. The second objective was to determine whether garlic extract treatment induced DNA damage to HSCC cell using connect. The third objective was to determine early and late apoptosis in HSCC cell by mean annexin 5 PI and caspase-3. So this slide here is for our cell culture, and then here this is the method we use for the MTT. The result from the MTT is shown here by this histogram that from 2 to 8 milligrams per ml of extract, the concentration, the the percentage of live cells is decreasing as the concentration of our extract increase. The second experiment run for the objective one was happened, which is also a cytotoxicity experiment. So this table here is just to show us the level, the decreasing, how the live cells were decreasing while the dead cells was increasing. Therefore, this is the histogram from the Trypan blue exclusion test, which is shown here in red, the level of cell death, while the green here is showing the level of live cells. So we can find out here that as the concentration increases as well for the extract, the level of the percentage of dead cells is also increasing, while the percentage of live cells is decreasing. For our second objective, what we did was the comment assay, which is the method used here. But in our lab, we have two ways to do the comment assay, by neutralizing or alkaline lysis. In our case, we use the alkaline lysis. And this is the result that we obtained from the comment assay. The picture here in A is showing a well-defined cell with the nucleus still intact in place. But from B to E, we can see a comet tail forming as the concentration of our extract increase, showing the damages on the DNA of the cell. For our third objective, we did annexin 5PI, which is a double stem as well, experiment. And from the annexin 5, what we found out here is that from B as well to D, as the concentration of our extract increase, also the percentage of apoptotic cells are increasing as well, because we go here from 4.8 to 23.1% at this level. But at E, what is happening, the level of the apoptotic cell has decreased. Why? Because at this highest concentration, most of the cell has went through necrosis. So that's why the percentage of apoptotic cell is not this high, because most of the cell have went through necrosis at this level. And also for the second experiment we did for our third objective was Caspase, which is usually used to show the late apoptosis. And here we can see that the result from Caspase is correlating the result from annexin 5, which is from B to D, is also showing an increase in late apoptosis. But at E, there's a decrease because it's already we have already a lot of debris. So this is why we are having this for the Caspase 3. As a conclusion, the data obtained from NTA and Trypan blue exclusion tests indicated that Gallium extract significantly reduced the viability of HS60 cell in a concentration dependent manner. The comment assay data show that Gallium treatment caused minimal DNA damage to HS60 cell, and the flow cytometry show a concentration response relationship between Gallium for the extract treatment and annexin 5PI as well as Caspase 3 positive cell. As a further study based on our in vitro finding, further study will be conducted to determine and understand the precise mechanism of action of Gallium in human leukemia HS60 cells. As acknowledgement, we acknowledge here Dr. Chunu, my main advisor, Dr. Yeju, the co-advisor of the Department of Biology, the National Institute of Health, which supported financially this project, and also the 92nd NTA Future Conference 2020 for giving us this opportunity to present our research. Thank you for your attention.